Hey, grade 10s, once again, your favorite uncle is with you. All right, so today we are going to be talking about motion in one dimension, and in particular, we are going to be talking about equations of motion. Some prefer to call it laws of kinematics. All right, so at the end of this video, we would have covered all of that. So if you haven't subscribed, please just make sure you do the right thing, hit that subscribe button. And if you need assistance in terms of maths and science, you're welcome to get in touch with us. All the details to get in contact with us will be on the description of this video. All right, so let's get into it. So by the end of this lesson, I want us to have touched on length and position, right? That's why I wrote them down there, right? I want us to have touched on distance and displacement, speed and velocity, as well as acceleration, right? So it will be quite a bit of a series, right? So I will also cover graph, but it will be on a separate video, equations of motion and the steps of solving those equations. Now let's get right into it. So firstly, when we talk about length and position, right? So usually we have what we call a frame of reference. So in this case, it's essentially just a point, a position, right, wherein we are going to start measuring from, right? So we are using that as our 0 point in a sense, right? So in this case, when we measure length, right, we can either take a direction, let's say towards the right, okay, or we can take a direction to the left from our frame of reference, right? Now, in this case, let's consider, let's say going to the right would be a positive direction. So I can actually move a length, in this case, let's say 80 meters to the right, okay, from my frame of reference, right? So in this case, this is what we refer to as distance, isn't it? Okay, so I'm going to talk about the difference now between distance and displacement. Now, ladies and gents, I want you to stay with me just a little bit. Okay, so when we talk about distance, so distance is just simply the total path length, right? So total path length that is traveled. So if you think about, if I go around in a circle, right? So if I say, the yard, or let's say, a soccer field or whatever it may be, right? A circular field, right? Going around in that field, if I say it's 400 meters long, so that's the total path length that I would have traveled, right? That is what I refer to as distance, right? So that is the distance. Now, on the other hand, when I talk about displacement, and please, I want you to note the difference. So distance is a scalar quantity, right? So if you haven't watched our videos on scalars and vectors, this would be a good time to go and do that, right? So distance is a scalar quantity. And now when we talk about displacement, this would be a vector quantity, right? So what is displacement? So displacement is a change in position, right, in a straight line from beginning to end point, to the end point, right? So remember, we are talking about a change in position, right, in a straight line. Notice that's very important to us. In a straight line, okay, from the beginning to the end point, right? So to the end point. All right, now in this case, I want you to note, let's go back to the story of our field. So we traveled around the field. Okay, so we went around the field and we went back exactly to the point where we started. So in terms of distance, I would have traveled 400 meters, right? But did I change position? So you'll note, if I started from A and I ended up at A, there was no change in position. So in this case, it would mean that my displacement would be 0. Okay? Now, let me just make a quick example again. So let's say I move across a field and I will go around and I get to the halfway mark. Let's say here's our halfway mark. So if it's a field that is 200 meters long, that is around. So in this case, what would be the distance that I've traveled? So in this case, it would mean that I have traveled a distance of 200 meters, okay, from A to B, right? A total distance. Notice in this case, it has absolutely nothing to do with, with direction, but it has everything to do with just the path length that I've traveled. Now, what would be the displacement? Now, please, I want you to note in this case. So the displacement in a straight line would be from A to B like that. Okay? So you wouldn't measure the displacement from A to B, right? The same way that you'd measure the distance. So our distance, in this case, we said, would have been 200 meters. But let's just make an example and say, look, just going around that field, perhaps the displacement, let's just say for argument's sake, the displacement from A till B in a straight line. Now note, it has magnitude and it has direction. Of course, if you were to go in a straight line, it would be shorter than the distance. So let's just say for argument's sake, that is going to be 120 meters, right? So now note, in this case, we said the distance would be 200 meters, but the change in position, the displacement, would be equal to 120 meters. Note, because it is a vector, we will say, between A and B, let's just say to the right, or let's say to the east, right? So let's say it went to the east. So 120 to the east. So it has both magnitude and it has direction. Okay? Now, supposing that we were now talking about velocity, and let's say we are talking about the speed, right? So remember, that's what we said we were going to touch on as well. So if I were to say to you, right, calculate for me the average speed. Now let's assume that a runner that was running across this field, let's say from point A to point B, would have taken, let's just say for argument's sake, it would have taken 1 minute. Okay, oh, that's a long time to be running 200 meters, but let's just say it took 1 minute. Okay, so if they were running for 1 minute, then it means that the time that it took to travel the distance of 200 meters would have been 1 minute. Now note, ladies and gents, if I'm going to calculate the average speed, now please, I want you to listen very carefully. So the average speed would be equal to the distance covered, okay, divided by the change in time, okay? So the time that it took. So if we were to calculate the average speed, now note there's a difference between average speed and instantaneous speed or instantaneous velocity, right? We'll talk about that just a little bit later. So if I note this, right, I'm going to say, well, he traveled a distance. Note speed is a scalar quantity. And that's why when I calculate speed, I use distance covered, which is also a scalar quantity. So I'm going to say this is 200 divided by, now note in physics, we use time, we use distance in meters, we use time in seconds. So what would be 1 minute? 1 minute is equal to 60 seconds, right? So I'm going to say this is 200 divided by 60 seconds. Okay, and that would give me my average speed. So in this case, of course, I'm going to say 20 divided by 6, right? So that's 20 divided by 6, and that gives us 3.33 meters per second. Right, so that's 3.33 meters per second. Now that's the average speed, ladies and gents. Now, if I were to say to you, calculate the average velocity on the other hand. Now note, when I take average velocity, so remember that velocity is a vector quantity. So average velocity says, I'm going to take the change in displacement, or my displacement, divided by the change in time, right? So I'm going to say, well, between A and B, what was the displacement? Remember, it is a straight line to the east. We said, well, let's consider it to be 120 meters. So in this case, we are going to say, well, our displacement was 120 meters east, and we're going to consider east to be a positive, and as a result, this is going to be divided by the change in time, which is 60, right? We still took 60 seconds, right, between A to B, right? So in this case, that would give us, so that would give us 2 meters per second. So this would be the average velocity that the person would have ran, in this case, from A to B. Right, so please note in this case, we always use average velocity, right? We use displacement over time, and we use, for average speed, we will use distance divided by time. Now, let's just consider very quickly, right? So what is displacement? So remember we said whenever we calculate displacement, we're going to say, well, it's going to be the position, the final position, minus the initial position, right? Now I want us to take an example whereby we are taking, linear displacement. So let's say here's a person traveling from A till B, okay? And let's just say from A till B would be, let's consider it to be 100 meters. Okay, so 100 meters from A to B, and now they decide to make a turn, right? And they're saying, okay, let's come back, let's say 40 meters. Okay, now they're moving from B till another position C. So this is from B till C. They make a U-turn of 40 meters, right? Now, what would be the displacement from A? Okay, so firstly, what would be the distance covered from A to C? So I want you to please note, in this case, I'm going to say, well, we are not going to consider anything about direction, right? So all that we care about is the total path length. So that would mean that we're just simply going to add 100 plus 40, and so that would give us 140 meters, right? But if I said to you, calculate the displacement, okay, between A to C. Notice, ladies and gents, what are we going to do, right? Now we need to regard, or we need to consider, a positive direction. So I'm going to say, right, let's say going to the right is positive, or going to the east is positive. So that means that this person was displaced. So it would be displacement, change in position from A till B, plus another change in position from B, change in position from B to C. Now, very important, ladies and gents. So in this case, it means that they were displaced 100 meters in the positive direction. So that means that they were going to be displaced 100 meters from A to B, plus, in this case, now we are moving in the negative direction. We are going from B till C. So we add there. Remember, it is a vector. So as a result, we're going to say that's minus 40 meters. So that means that in this case, the change in displacement, or the displacement from A till C, would actually be a positive 60 meters, right? So that means that it would be 60 meters in which direction? To the east. Remember, we considered that going to the east is positive. All right. So that's very, very important. Okay. But I want you to also note in this case. So suppose that I said to you, they were displaced now back to A, right? So they moved from B back to A. So how would we calculate our displacement? It means that the total displacement, so the displacement there, would be equal to, so change in position from A to B plus another change in position from B to A. So that would mean it traveled 100 meters in the positive direction plus another 100 meters in the negative direction. And what do you note there? That gives us 100 minus 100, okay? And that will give us a total displacement of 0, okay? So that is very important to note, that our displacement would end up being 0 displacement if they go back to the same position. However, if we were looking at the distance, right, how would we calculate that distance? That would be, of course, 100 meters plus another 100 meters, and that would give us 200 meters, the total path length that would be traveled. Okay, right. Now, let's go back to our initial C. Let's say they ended up at that C position there. And we said C was 40 meters from B to C, rather, would have been 40 meters, right? Now, if this person would have taken, let's just say for argument's sake, right, this person takes about 30 seconds to get from A to C, right? So if I said to you, calculate the velocity, right, from A to C, if it took, let's just say if it took, we said if it took 30 seconds to reach point C, from A, right? So what are we going to do? So when we want the velocity, we said whenever we want the average velocity, right? So average velocity, this is going to be the change in displacement, or rather, this is going to be displacement divided by the time. Okay, so what are we going to do there? Going to say, well, what was our displacement? We said the displacement was 60 meters. You remember we calculated it. We said 100 minus that 40, that gave us 60 meters, right? So our displacement was 60, and we divided by the time, and remember that time must be in seconds, so that's 60 divided by 30, and so what that simply means is that it would give us 2 meters per second. Okay, right, but note, because we're dealing with average velocity, that means that we have to now consider the direction, right? So we get a positive velocity, it means it must have still been to the east, okay, or to the right, whatever you want to use as the, for direction, right? But if I said to you, calculate the average speed, okay, so what does that give us? So we know, we would have said, well, that's going to be the distance divided by the change in time. And so a total distance from A till C would have been 100 plus the 40, the total path length. So that would have been 140 divided by the time that it took, which is 30. So that would give us 140 divided by 30, and that would give us 4.67 meters per second, that is. Okay, note that velocity is measured in meters per second, and please guys, do not forget this exponent -1 for the per second, right? Sometimes they do use the meters per second like that, but that's an old system. It is no longer really preferable, so please just stick to the one that I have shown over there. Right, now ladies and gents, that is how we are going to calculate the difference, or that is the difference rather, between speed and velocity, right? So now what I would like for us to do is just to look at the next thing which we're going to look at now. We're going to be, if we go back to where we started from, right? We said we've looked at speed, we've looked at velocity. I want us to cover now something that has to do with acceleration, right? So if we look at average speed, okay? So we've spoken about average speed, and we've spoken about velocity. Now, what is acceleration? Okay, so if we look at acceleration, now we say acceleration is the rate of change in velocity. Okay, so acceleration, in fact, I didn't even give you the formal definition for average speed or velocity. So velocity is the rate of change in displacement, or you can say it is the rate of change in position, right? Or sometimes they say it is the change in displacement over the change in time, right? Whereas we said average speed, in this case, this would be the distance divided by time. Now, acceleration is the rate of change. Anytime that we use rate, remember that it has to do with division by time. So we say that it is the rate of change in velocity, so it's change in velocity divided by change in time. Okay, so now let's consider, suppose that we said to you, calculate the average acceleration, right? So when we got to, let's go to that point there, right? Let's say we got to point C, at a speed of 2 or at a velocity of 2 meters per second, right? When we would have started from rest, okay, right. Now remember, we had said that we started 0 meters per second, we got to C at a speed or at a velocity of 2 meters per second, right? And now what we want to do is to calculate the acceleration, right? And if you remember, we said we are assuming that the time that we took was 30 seconds, right? So that would mean if I'm calculating the average velocity, the acceleration, that would be final velocity minus initial velocity divided by the change in time. So my final velocity, that was 2 meters per second. Okay, we don't need to use our SI units there. Minus, what was our initial velocity? Remember, initially it was at rest. Okay, this is divided by the time that it took, and this was 30 seconds. Okay, so we can calculate that. We can say 2 divided by 30, and that would give us an acceleration of 0.067 meters per second squared. All right, so that is how we would get the acceleration there. So acceleration is the rate of change in velocity.